Good evening, everyone. I know it's the last talk of the day and parties on everyone's mind. So I'll try to keep this talk a brief. So what are we waiting for? Let's dive right in. We all rely on passwords for almost everything, from banking to emails. Almost we can think a lot of options here. But what would happen, let's say, if you are in middle of an urgent task and you forget your password? Let's think more worse scenarios. What if your password gets compromised in a cyber breach? I know it's frustrating. So, in today's digital era, it's time to rethink security. Why not enter Passkeys, a secure, user-friendly alternative to passwords, which can actually save us from a lot of nightmare scenarios. So, in today's talk, we'll explore what Passkeys are, how they work, and why they are a game changer for security and user experience. Plus, I'll show you how you can start integrating Passkeys in your Android apps to prepare for passwordless future. So brace yourself for live demo, and fingers crossed that net works. Before moving ahead, let me introduce myself. I'm Ayushi Gupta, a GDE WTM ambassador. So if you have any questions around this program, I'm going to be around. And currently, I'm working as an Android engineer at Zalando, based out of Berlin. More details could be found at my website, and feel free to connect with me on Twitter. Introducing my partner in crime, who is unfortunately not here with us today because of visa constraints, Gaurav Bansal, who is a co-founder at GeoTestRack based out of Mumbai. He is an XR expert and AI/ML enthusiast. Feel free to connect with him on Twitter. Login. Login process is a critical component of the majority of the apps. If we check industry insights, around 60 to 80% of mobile applications include some form of login or any authentication mechanism. Let's take a closer look at the various login methods currently available. I know the first one, the traditional classy username password combination, which is simple, quite familiar, but comes with significant vulnerabilities. It's highly susceptible to phishing, password fatigue, and brute force attacks, making it quite a less secure in today's digital landscape. Many users turn to password managers to store and create a strong password. But the point is, how much? The number of users who actually use password managers are pretty low, leaving high security gaps. Then came email and password combination, trying to make the email recovery quite easier. But again, they are susceptible to email phishing and password breaches. These both methods are quite familiar in the industry, but they highlight the need for more robust and secure alternatives. So, to enhance the security methods, developers came up with new options, such as two-factor authentication, which is like you're adding a second layer of security by adding a one-time code, or which could be through SMS, or let's say email, or an authenticator app. No doubt, it significantly boosts security. But again, it's adding an extra step for your users, which could be inconvenient and may even add like a cost to your pockets. Then came MFA, multi-factor authentication, which goes a step further by combining two or more authentication methods, such as password, maybe your facial recognition or fingerprint, plus SMS code. Highly secure, no doubt, but again, more complex, making the login process quite cumbersome for users. So, as user convenience became a focus, new login methods were emerged, such as social login, where you are using to sign in with your social media accounts, reducing the friction of login, as well as remembering the passwords. Again, it involves sharing the data with third parties, and may even come up with additional cost. Biometric authentication, very fast, very secure, but you need a compatible hardware for it. Then came SSO, single sign-on, where you're using a single login across various services. But what if the SSO provider gets compromised? All the connected services are at risk. All the traditional authentication methods, including passwords and SMS OTP, they are relying on knowledge-based system, which are not only a hassle to remember, but also susceptible to phishing, harvesting, and a lot of replay attacks. If we see the statistic, which actually highlight the extent of these issues, passwords are responsible for more than 80% of data breaches. A typical user kind of manages over 90 online accounts. Let's say you have to reset a password, then each password reset costs an average of $70 in a help desk labor. Not only that, up to 51% of passwords are reused across different sites. All of these figures underscore the need for more secure and user-friendly authentication system. So, why not, let's say, goodbye to passwords? And it's time to say hello to making our digital lives more simpler and more secure with Passkeys. I know most of you would be thinking, what is a Passkey? Let's try to seek answer on this. Passkeys are passwordless authentication methods, which is built on FIDO, Fast Identity Online Standards. They're actually designed to overcome the weaknesses of traditional passwords. A passkey is a digital credential which is linked to a user account and a specific website or an application, which is like you're enabling secure phishing-resistant authentication without the need for passwords or any extra authentication. You're actually replacing outdated methods. It's like embodying FIDO's vision for passwordless future. I know you would be thinking, how does it work? Let's try to find out. There are two phases of this journey that we're going to talk about. First phase is passkey creation. Obviously, this is how the journey of login starts on a general app. You click on a register button. What happens post that? Then, on the behalf of user, the client, which could be a native app or a web app running across the browser, it takes the input and start calling to the backend to get the challenge. What is a challenge? A challenge is a random generated server string which contains enough entropy, making it guessing it like quite infeasible. And the ideal is that it should be at least 16 bytes long. That's a must. Now, the server has created the challenge. It has given back it to the client. Now, client calls WebAuthn API to create with that particular challenge. It's like it's handling over the challenge, which results in a key pair generation, which is private key and a public key. Private key is the passkey, and we are using this private key to sign the challenge that we have received from the server. And it's gonna be, like this particular private key is going to be stored on your device secrets, I would say secure hardware, where this private key gonna be stored. Now what happens? The private key with which you sign the challenge, it's stored on the user's device. The matching public key, a credential ID, as well as the signed challenge, which we have signed with the private key, is all collected and given back to the server. But before doing that, you might have to enter your biometric or PIN. It's like you have to give a consent that, hey, yes, you can share out the public key of my device. Now, to finalize all the process of passkey registration, the client has already sent the public key. We are not sending out the private key. We are only sending out the public key. Public key plus credential and some username plus some metadata of the user to the server. Now what does server does? It again re-verifies the signed challenge with the public key. It's like it's making sure that yes, the user was genuinely in possession of the device, and it saves the username and public key matching that, yes, this username, this public key, let me store it in my data. And that's it. It's all done. Now what would happen the next time when you try to authenticate? First, the client would call again to server to get a challenge. Challenge the same random string. As soon as the server gives out the random string, the client will call WebAuthn API to get challenge, which results in prompting the user for verification. Now that verification could be biometric or a PIN. It's like you're giving a consent key, okay, you can open the secure hardware and take out the private key. And again, the private key would be signed with this particular challenge. The signed challenge, as well as the username and the credential of the used passkey, are returned by the function. Now, to finalize the entire process of authentication, the client sends out the signed challenge, the username, and the credential ID back to the server. The server now checks if the username and credential ID are known, like generally you are the previous user who came to me. If so, it will pick up the public key to check the validity of the signed challenge. If the signed challenge can be successfully verified with the public key, the server can safely assume that the user was in possession of the device. And it will create a session or hand out an authorization token. That's it. In this entire journey, you were never asked to enter any of your password. You're just using your fingerprint or the PIN, I think, which you all know because you're using your devices. We are not handing out the private key. It's already in your secure device. It's not going out. And only the public key of the user is sent out to the server. Let's look into where the passkeys are in support. So in Android apps, passkeys are supported through Credential Manager. Credential Manager support passkeys, passwords, and a lot of identity federations. Passkeys are supported on devices that run on Android 9 or higher. Not only that, Chrome or Android OS 9 or later support passkeys. So passkeys which are generated in Chrome are actually stored in Google Password Manager. So now, these passkeys are going to be available on all other Android devices which have Google Password Manager, and you are logged in with the same Google account. So let's say you logged in on Chrome on a website, and you have a passkey created. Now you're using your phone, same website, and it won't ask for your password. You can easily log in with the passkey which you have stored already. Not only that, Chrome on Windows store passkeys in Windows Hello, which doesn't synchronize them to other devices, like as of now, like October 2023. But when user tries to sign into the website for the first time on Chrome or Windows, you can actually scan a QR. Let's say you have a phone which has Google Password Manager, so you can scan a QR and create the passkey of the same website on your phone. That's it. Chrome on Mac OS, I think 13.5 and later, can use iCloud Keychain to store passkeys. So passkeys in iCloud Keychain are synchronized across devices on the same Apple ID. And that's it. It would be, you can magically use all the passkeys across all your Apple devices. Let's talk about Linux. Chrome on Linux doesn't support passkeys with a built-in platform authenticator. But Linux users can use passkeys from another device, like we talked, such as an Android device or an iPhone, by scanning a QR code. Passkeys are not something which are in an experimental stage as of now. They have been tried, tested, and already been in use by major of the companies, like Google, PayPal, DocuSign, maybe Mercari. So what's stopping us? Why not we start integrating it in our apps? But there are few integration requirements that we have to look into. First is, obviously, you would need a backend which stores public key and user metadata, and so that each passkey information knows, like the server knows which passkey it's interacting with. Then comes Credential Manager API. API used for retrieving and storing users' passkey with credential providers available on the device. App, obviously you would need a front end, which will be communicating with the credential manager API and actually sends and fetch requests to the backend. Lastly, but important enough, is the credential provider. The credential provider on the user's device, this provider actually creates and stores user's passkey. This could be on the same device, for example, Google Password Manager, and from Android 14, if you are using Android 14, some third-party credential provider could also be used. So these are the major 4 things that we would be requiring. I guess it's a time. I hope everything works. Okay. I guess just a very simple UI. I'm going to start with the basic flow, which is the registration flow. I'm going to enter my name. Now you would ask why you need an email ID. So I'm using email right now as a form of validator. I want to make sure that this user is a genuine user. So let's say, should we use the temp email, or I guess let me use my personal email. Okay, as always, the internet thinks. I think this is already registered. Let me try. I'm just using hello@gmail.com. Okay, so right now, sorry guys, I didn't look at the screen. Okay, so I have entered an email. I'm using a hard-coded OTP as of now, so you can make sure that your server talks to the backend and the email OTPs are generated. So right now I've hard-coded it just for the demo purpose. And let's see what happened. Okay, so right now what we are seeing is the register passkey function. Should I make it a bit more bigger? Okay, let me try it sorry. Okay, it's not working, I guess. So let me tell you what's actually happening. We were talking about the challenge the whole time, which is a random generated server string. So that's where it happens. Passkeys.convert and get a new challenge. So your server is creating a random string, and we give out some user metadata information, which is like relying party information, user ID. I think we could see the response, I guess. So yeah. It's some challenge, which is a random generated string. You could see it on the screen. Then RPID, which is the relying party information. And the user information, which is like this we were talking about, plus some credentials that would be handed out. I guess I have to do the entire flow again because I clicked on cancel. Okay, now as soon as the server gives out this response, let's try to see on the Android side what happens. We were talking about credential manager API. So first thing is we create a request to get the public key of this particular credential. So an application, like this is the base request class for registering a credential. And if you see it, it's coming from Android X credentials library. It's already been created for you. Now, as soon as the request is created, hold on for a moment. Okay, so you can see there is a launch UI which is coming in, right? from where this UI is coming in. So Credential Manager is actually creating the launch UI for you. It will create a UI. It will also collect consent and any other metadata which is needed from the user to register a new user credential. So you could see it's asking me to verify my identity. So let me enter that. I know. Let's add one more. And that's it. Everything is successfully created, and you enter on the login page. That's it. You were never asked to enter any form of password. Do you remember the email I entered? Sorry, is someone attentive? What was the email? Okay, let's see. Hello? 12? I guess @gmail.com? Okay. So when I'm trying to log in with the same email, it's again asking me to use the stored passkey. I'm not entering any of the passwords. So what would happen, like what's happening at the background? So here, like the same thing that we have seen, we asked for a challenge from the server gives out a challenge, and again, this UI is coming from Credential Manager API. And that's it. I would give the option that yes, sign in. It will again has to verify that yes, I'm the one who is doing it, because it will be taking out the private key which is stored in a secure vault, signing the challenge, and giving back the public key for the again flow. So that's it. You have logged in into the app. In this entire journey, you could see it's highly secure. You are using your biometric or your PIN, and you are nowhere using passwords. There are few privacy considerations that come in with Passkeys. Passkeys have been designed with user privacy in mind. With Passkeys, the user's biometric information is never revealed to the website or the app. And biometric material, again, never leaves the user's personal device. On the other hand, Passkeys on their own don't allow tracking or of users or devices between sites. So the same passkey is never used with more than one site. Passkey protocols are carefully designed so that no information is shared with sites which can be used as a tracking vector. Passkey managers protect passkeys from unauthorized access and use. For example, let's talk about Google Password Manager. It actually encrypts passkeys secrets end-to-end. Only the user can access and use them. And even though they are backed up to the Google servers, even Google can't use them to impersonate users. So making it highly secure and private. Let's look into the security considerations as well. Passkeys use public key cryptography. Public key cryptography reduces the threat from potential data breaches. So when a user creates a passkey with a site or an application, this generates a public-private key pair on the user's device. Only the public key, like we have seen, is stored on your backend. But this alone is useless for an attacker. An attacker can't derive the user's private key from the data stored on the server, which is actually required to complete the authentication. Like you have seen, without me giving the fingerprint or the consent, the authentication journey was not completed. And as passkeys are bound to a website or app's identity, they are safe from phishing attacks. The browser and the operating system actually ensure that the passkey can only be used with the website or app actually which created them. So it actually frees you from being responsible for signing in into a genuine website or app. So it's all highly safe and secure. But there comes few best practices that you have to look into when you are developing Passkeys. First is utilize Android's native APIs. For example, biometric prompt to ensure seamless Passkey integration. Not only that, make sure you implement a fallback authentication. For example, biometric or PIN for users who may not have Passkeys enabled. Then comes educating our users, which is we being developers, we have to be responsible for that. So clearly communicate the benefits and the process of using Passkeys, actually to encourage adoption. Not only that, ensure that cryptographic keys are stored securely using Android's trusted execution environment, or maybe similar secure storage option. Then comes user experience optimization. It's like design the UI UX to tell why is this important. So let's say when you're building for your own existing login system, you can have the existing sign-in journey and then give an option to the user to enable Passkey for your apps. So that user knows that, okay, this is an extra step could be useful for me and I don't have to give password again. And last, but again important, keep the app updated to support the latest security protocols and Passkey standards. So let's have a recap. We have seen in these slides the innovative concept of Passkeys, a secure and user-friendly alternative to traditional passwords. We have actually seen how public key cryptography is working. In brief, effectively eliminating the need for passwords and reducing the risk of cyber breaches. We actually delved into the benefits that are coming with Passkeys, such as enhanced security, improved user experience, and streamlined authentication process. I hope the integration process just give you a hope that you can also start adding Passkeys into your Android apps. It's like paving the way for passwordless future, offering a more secure, more seamless experience for the user. Let me share out few references with you so that you can start integrating Passkeys into your Android apps. So all the demo is up on the GitHub. You can try, test it out, and let us know if there is something missing. OK. And lastly, thank you, everyone, for being the patient audience. I guess I say it right. Obrigado. Happy coding, guys.